You are standing in front of a stone wall. No crane built it, no steel beam holds it up, no blueprint existed when the first stone was placed, and yet it has stood for thousands of years. Here is the uncomfortable truth about ancient construction. The people who built the world's most enduring structures had almost nothing we would recognize as a tool. No measuring tape, no level, no power equipment. What they had was time, observation, and a brutal trial and error process that lasted generations. But calling them primitive would be a mistake, a significant one. Take Stonehenge. The Sarsen stones used in its outer ring weigh up to 25 tons each. They were quarried roughly 25 miles away in Marlborough Downs. That means ancient builders, working around 2500 BCE, somehow moved multi-ton slabs across uneven terrain, stood them upright, and placed horizontal capstones across the top with enough precision that several still sit in position today. No wheels, no pulleys in the modern sense, no GPS coordinates. Archaeologists have spent decades reverse engineering how this was possible. The leading models involve wooden sledges, greased tracks made from animal fat, and teams of people pulling in coordinated rhythm. Experimental archaeology, where researchers actually try to replicate ancient techniques, has shown that around 200 people pulling together on ropes can move a stone of that size. It's slow, it's exhausting, but it works. And that points to something crucial. The real tool ancient builders had was not made of stone or wood. It was collective coordination, the ability to organize dozens or hundreds of people toward a single sustained goal across years, sometimes decades, is a technology in itself. It just leaves no artifact behind for archaeologists to dig up. In Egypt, evidence from workers' villages near Giza shows that pyramid builders were not slaves. They were paid laborers who received rations of bread, beer, and meat. They worked in rotating crews with specific names. They had supervisors. They had schedules. That organizational infrastructure is what made the pyramids possible, not some lost ancient secret or alien intervention. Just humans, organized at scale, doing hard physical work with remarkable consistency. The ramps used to lift stone blocks are another example of elegant low-tech problem solving. Straight ramps, spiral ramps, internal ramps. Researchers still debate which method was used at Giza, but all of them rely on the same simple principle: reduce the angle of incline and you reduce the force needed to move something heavy. Ancient builders understood mechanical advantage not as a formula, but as lived physical intuition developed over generations of moving heavy things. And the tools they did have were surprisingly effective. Copper chisels could cut limestone with precision. Dolerite, an extremely hard rock, was used as a pounding stone to shape granite. Wooden mallets, bone tools, and abrasive sand were all part of the toolkit. Simple, but in the hands of someone who had spent their entire life doing one specific task, cutting a particular type of joint, shaping a particular type of block, simple tools produce extraordinary results. Ancient builders did not have surveying equipment, but they had something that took centuries of accumulated knowledge to develop: an intimate understanding of the ground beneath their feet. Choosing where to build was itself an engineering decision. The Egyptians placed the Giza pyramids on a plateau of solid limestone bedrock, not sand. That bedrock acts as a foundation stable enough to hold millions of tons of stone across 4,500 years without significant settling. That choice was not accidental. It reflects a sophisticated read of the landscape. In the Andes, the Inca built Machu Picchu at an elevation of nearly 8,000 feet on a ridge between two mountain peaks. At first glance, this seems impractical, but the location was chosen partly because the underlying granite was strong and the ridge naturally drained rainwater away from the structures. The Inca also built an elaborate drainage system of underground channels that prevented the terraces from flooding and eroding. Around 60% of Machu Picchu's construction is actually underground, drainage infrastructure that is invisible from the surface but essential to the site's survival across centuries. Ancient builders also used the sun as a precision instrument. By tracking shadow positions across seasons, they could orient structures with accuracy that still surprises modern surveyors. The Great Pyramid at Giza is aligned to true north with an error of just 0.05 degrees. The tools used to achieve this likely included a merket, a sighting instrument made from a palm leaf rib, and careful observation of stellar positions at night. No GPS, no compass, just repeated, patient observation of the sky. Level surfaces were achieved using water. A channel carved around the perimeter of a foundation filled with water gives a perfectly level reference line, because water always finds its own level. This technique, used across cultures from Egypt to Mesoamerica, is so reliable that modern builders still use a variant of it today in a water level tool. And then there is the question of proportion. Many ancient structures follow geometric ratios so consistent that they clearly reflect deliberate mathematical planning. The Parthenon in Athens uses the golden ratio in its facade proportions. The Great Pyramid's slope angle produces a ratio of circumference to height that approximates pi. Whether these were intentional applications of abstract mathematics or the result of using consistent rope and peg geometry is still debated. But the precision itself is not in question. It exists in the stone. The key insight here is that ancient builders were not guessing. They were applying knowledge that had been tested, refined, and passed down through generations of craftsmen. The knowledge lived in practice, in how a mason held a chisel, in which way a ramp was graded, in where a foundation was dug. It did not need to be written down to be real or precise. There is one more dimension to ancient construction that rarely gets discussed. The builders were not designing for a decade or a century, they were designing for eternity, and that changes everything about how you build. Modern construction optimizes for cost, speed, and a design lifespan of roughly 50 to 100 years. Ancient monumental construction optimized for permanence above almost everything else. That single difference in intention produced radically different choices at every stage of the process. Consider the interlocking stone technique of the Inca, called ashlar masonry. Stones were cut to fit together without any mortar. The joints between them were shaped so precisely that you cannot slide a piece of paper between them in many places at Sacsayhuaman near Cusco. The stones also have slightly irregular shapes, not rectangles, so that each one locks into its neighbors like a three-dimensional puzzle. When an earthquake hits and the Andes are seismically active, these walls flex slightly and then resettle. Spanish colonial buildings built with mortar next to Inca structures have collapsed repeatedly in earthquakes. The Inca walls stand. The builders of Çatalhöyük in modern-day Turkey, one of the world's earliest cities dating to around 7500 BCE, used mud brick construction. Mud brick sounds fragile, but the residents replastered their walls multiple times per year, maintaining the structural integrity and also leaving behind an archaeological record of layered plaster that researchers can read almost like tree rings, each layer representing a season of habitation. In northern Europe, the long barrows and megalithic tombs built from around 4000 BCE used a corbelling technique to create interior spaces without arches. Stones were stacked in slightly overlapping horizontal layers, each layer projecting a little further inward until they met at the top. The result is a self-supporting stone ceiling that has held for 6,000 years without mortar, without keystone, without any of the structural principles that would later define Roman arch construction. And there is something philosophically significant happening in all of these examples. These builders were investing extraordinary effort in structures they themselves would never see completed and would never see crumble. They were building for people who did not yet exist. That requires a relationship with time that is almost incomprehensible from a modern standpoint, a patience and a collective commitment that stretches across generations. We look at these structures now and ask how they were built without technology. But maybe the better question is, what kind of relationship with the world produces that level of sustained commitment? Because whatever ancient humans lacked in machines, they compensated for with something that is genuinely hard to replicate: a willingness to work slowly, carefully, and with the full weight of the future in mind. Ancient humans did not build without technology, they built with a different kind of technology, one made of knowledge, coordination, and time. If this made you see those old stones differently, subscribe. A new video drops every week.